Now we are going to discuss how can we find a limit of a function at infinity. If you want to find the limit f of x when x approaches infinity or x approaches to negative infinity, if you have a look here, limit 1 over x when x approaches infinity equals 0, and limit 1 over x when x approaches to negative infinity equals 0. And if you have a look at the rest of the rules, you can deduce that limit 1 over x to the power k when x approaches infinity equals 0 for k greater than 0. Now we have some examples here. Example number 1. Find the limit of this rational function when x approaches to infinity. The first step, if you try the direct substitution, you will have infinity over infinity. It doesn't make any sense because it is indeterminate form. So we have to divide by x to the power 2, or let me say we have to divide by x with the greatest power in the denominator. So after dividing each term by x squared, we have here 3x squared over x squared is 3. Negative x over x squared is negative 1 over x, negative 2 over x squared, and similarly down in the denominator. And if you use the previous rules, so we have here limit 1 over x 0, 2 over x squared 0, 4 over x its limit when x approaches infinity 0, 1 over x squared its limit 0, so the final answer is 3 over 5. Another example here. Again, we have to divide by x with the greatest power in the denominator. So we have to divide by x to the power 3. And after simplifying here, after simplification, we can find that the final result equals 0, because limit of 1 over x squared and limit of 1 over x power 3, limit 2 over x squared, limit 4 over x power 3 when x approaches infinity equals 0. So, and limit 2 over x again equals 0, so the final answer equals 0. Find the limit of this rational function when x approaches infinity. We have to divide by x with the greatest power in the denominator here. So we have to divide by x squared. So we have here this form after simplifying this problem here. So we can use the previous rules when limit 1 over x and limit 1 over x squared, limit 2 over x, limit 4 over x to the power 2 when x approaches infinity are zeros. And when x approaches infinity here, so we have the final result, which is infinity, which means that the limit does not exist.